Okay, we continue with common analytical problems. The first one is qualitative analysis. This involves identifying products of a chemical reaction, screening athlete's urine for the presence of a drug, banned drugs. Okay. Another example is determine spatial distribution of lead on the surface of airborne particulate. So this type of qualitative analysis involve the development of simple chemical tests. Okay, so most qualitative analysis currently use high-end instrumentation, for example, FTIR, okay, spectroscopy, or NMR spectroscopy. Okay, NMR normally will determine the presence of proton, okay, hydrogen, and also carbon 13. Okay, okay, in of a chemical sample. Okay, and then if there are normally will determine the functional group. Example functional group is OH, okay, hydroxyl group, CH3, okay, CH2, okay. So those are example of functional groups. um, Second one is quantitative analysis. So we have covered that quantitative involve value, okay, a number, okay. So example will include elemental analysis of newly synthesized compound, okay, measuring the concentration of glucose in blood, okay, especially for diabetic patient. Determine the difference between the bulk and also the surface concentration of chromium in steel. Okay, so what is the concentration of chromium in steel at the surface, as well as the um, the bulk. Okay, so the next analytical problem is characterization analysis. Okay, so characterization analysis normally will involve development of new methods for characterizing physical and chemical property. Okay, for example, determine of chemical structure. Okay, chemical structure of a compound. Um, these will involve the usage of um, high-end instrumentations, like qualitative analysis just now, in which it use FTIR to measure the functional group, and NMR to identify the structure based on proton and also carbon. Another example is determine equilibrium constant, okay, particle size. This one normally we use SEM, okay, scanning electron microscope. This will determine the particle size, whether it's in nanoscale size or micro scale size. Okay, so SEM also will measure the structure of the surface of analyte of interest. Okay, whether the structure on the surface is porous or not. Okay. Okay, the next analysis is fundamental. So fundamental goes back to the theory behind any analytical method. Okay. For example, we already have the standard method uh, to analyze, to measure pH, for example. So therefore, chemists have improved that standard method to measure pH, for example. Okay, so that it goes back to the fundamental analysis. So it's actually extending or improving uh, the theory, okay, that is already available. Okay. Okay, so this is example. I have attached also the article on this in Ellipse, so you can read the detail of the article. Okay, so the question is bottled water safe? Okay, mineral water bottle. So these are the different type of plastic. Okay, different type of plastic used to make plastic bottle. Okay, so tests have been conducted on the major brands of bottled water. Okay, and have found that nearly all of them contain tiny particles of plastic. Okay, and these are the percentage. Okay, bottle made of PP, polypropylene, have 54%, okay, of tiny particles of plastic, followed by plastic made of nylon, okay, 16%, and then polystyrene, PS, 11, polyethylene, 10, polyester or polyethylene terephthalate, PET, 6. So this is the common plastic used for mineral water bottle. So if you purchase a mineral water bottle, you look at the bottom of the bottle, so you will find a number at the bottom of the bottle, and it's in triangle, something like this, arrow. Okay, this shows that it is the material of the plastic used, and it's recyclable. And normally you will find number one. Okay, for mineral water bottle, number one is actually referring to PET, polyethylene terephthalate. Okay, 6%. And then the least particle of plastic is found from bottle made of other material. Okay, for example, Azlon, polyacrylates, and also copolymers. Okay, so based on the article, we can conclude that, okay, bottle made of polypropylene, okay, is the most safe or not. Okay, that is for you to think. Okay, next is quality assurance. So what is quality assurance? So it is the steps taken during analysis to ensure that analysis is under control and it is properly monitored. Okay, so in any institution or even factories, there must be a quality assurance department. So this department will ensure everything is under control and everything is properly monitored, so that no problem occurs, especially in factories that produce products. Okay, so the product produced are up to the spec expected. Okay, one of the most important aspect of quality assurance is quality control. Okay, so quality control include specific formal goals. Okay, means they must achieve the objective. We call them as data quality objective. Okay, so they will collect data to assess the quality of the data. Okay, and from there they do statistical assessment of the data quality, and if the statistical assessment is not up to the expected range, remedial measure must be taken. Okay, for example, in factory producing food. Okay, so once in a while they will take random samples of the food and do analysis of the food, and the food, for example, cannot contain certain limitation of chemical, for example, and if it exceeds the chemical value of that specific chemical compound means something wrong during the production. Okay, so they have to take action. Okay, this is where remedial measures must be taken. That's the importance of QC, to ensure everything is smooth. Okay, so a successful program of quality assurance, quality control not only ensure that sampling process is in control, but also presents estimates of the sampling error. So if some of the component of the sampling is not in control, then remedial response must be taken. Okay, as soon as the problem is discovered, like I mentioned just now. Okay, samples of food taken randomly. Okay, and if the component to be analyzed in the sample is out of limit of the range, and then um, they have to go back to the production line. Okay, so it is important to communicate between the samplers and the analyst once problem has been identified. Okay, so normally samplers and analysts are different person. So once the analyst had come up with the result which is not in the expected range, they have to inform the sampler so that the sampler will identify from where the sample has been taken. Okay, and they have to take another sample. For example, if the value is the same, then something wrong during the whole production line. Okay, so they have to stop the production and go back to the early stage, probably during the preparation of the food. Okay, during the washing or things like that. So this is the summary of a QA program, quality assurance program. So initially, okay, the first step is to identify problem. Okay, if you look at this program, it's more or less the same as the steps taken under quantitative analysis. Okay, but it's more simpler. Okay, similarly, it identify problem means determining what type of information needed. Okay, whether it's qualitative, quantitative, characterization, or fundamental. Okay, and then it established the context of the problem. From there, then we can design the experiment procedure. Okay, suit suit to suit the uh, problem that has been identified. Okay, once the procedure has been identified, then we can conduct the experiment. So if anything goes wrong in this step, then we go back to the procedure. Probably the selected procedure is not suitable for. Okay, then once the experiment has been conducted, we analyze the data. Okay, if the data analysis, okay, leads to error, then during the interpretation, then it has to go back to the experimental method, or it can go back directly to the procedure. Probably the selected procedure has is not suitable. Okay, if the result is okay, then you can proceed to the last step, which is propose a solution which answer the problem identified in the first stage. Okay, this here from number 2, 3 and 4 we call loop. Okay, QA program loop. So this is where we do the QA and QC. Okay, this process here. Okay, okay, next we move on to units of concentration. Slight introduction to units of concentration, and we will look into more detail of this in the following learning unit. So what is the definition of concentration? It is amount of solute per amount of solution. Okay, one of the unit concentration is molarity, so this is the most common one. Okay, and we can use the symbol capitalized M. Okay, so molarity is defined as number of mole of solute per liter of solution. Okay, molarity is mole of solute per liter of solution. Mole per liter. Okay, for example, 1 molar hydrochloric acid solution means it contains 1 mole of hydrochloric per liter of solution to prepare this 1 mole. Okay, liter of per liter means it may be used distilled water or double distilled water or deionized water. Okay, to prepare this 1 mole hydrochloric acid solution. Okay, if we use millimole, then molarity times mil. If we use mole, then molarity times liter. Okay, mole means molarity times liter. If millimole, then this is milliliter times molar. Okay. Okay, the next type of concentration is formality F. So it is defined as number of formula units regardless of chemical form per liter of solution. For example, 1 formality hydrochloric acid solution. Now, what is the difference between formality and molarity? Okay, so if in 1 molarity hydrochloric acid solution is actually means 1 molar of H plus and 1 molar of Cl minus. Okay, however, for formality, okay, it represent the total amount of HCl in total HCl, not individual H plus or Cl minus. Okay, so this would make not much different because this is 1 to 1, but it will be significant if it involve different ratio, for example H2SO4. So I will explain this in detail in the following learning unit. Okay, so the next unit of concentration is normality, capitalized N. N means number of equivalent of solute per liter of solution. So it depends on the number of equivalent. So it is defined, it is represented by a small letter N. Okay, so number of equivalent will depends on chemical species involved in a reaction. Okay, so basically N will depend on type of reaction. Now first let us look at redox reaction. Okay, so redox reaction, okay, is reducing and oxidation reaction. Okay, so in this redox reaction, number of electron released by reducing agent, okay, is similar as number of electron accepted by oxidizing agent. So let us look at one example of redox reaction here. Okay, between iron 3 plus and tin 2 plus. Okay, so iron 3 plus undergo reduction because that 3 plus, okay, reduced to 2 plus, whereas tin undergoes oxidation because the electron 2 plus, okay, increases to 2, becomes 4 plus. Okay, so this tin undergo oxidation, iron undergo reduction. So the number of electron, okay, gain per iron 3 plus is 1 electron. So the number equivalent for iron 3 plus is 1 electron, whereas number of equivalent for tin is 2 because it loses 2 electron per tin to plus. Okay, so that is redox reaction. Okay, so number equivalent will depend on the type of reaction. So the next type of unit of concentration is molality, small letter m. So it is defined as the number of moles of solute per kilogram of solvent. So the difference between molality and molarity is the denominator here. Molarity, this one is in liter. Molality, the denominator here is in kilogram. The other unit of concentration includes P function. So if you look at your calculator, you will find the symbol log. One of it is log symbol here. Okay. So pH is calculated by pressing the button negative log. You have to press the negative button first. Okay, the negative symbol, the minus symbol first. Minus symbol, then you press log, and then you press the concentration. Then it will give you the pH. PCl, you negative log, chloride concentration. Okay. So this system is used for dealing with large concentration changes. That's why normally the unit is, sometimes you find it in power form. Okay, times 10 power of negative 9 times 10 power of negative 8. Okay. The next type of unit of concentration is weight volume ratio. Okay, so you will come across either weight over weight percent, volume over volume percent, or even weight over volume percent. Okay, so percent means per 100% unit of sample. The next type of unit of concentration is ppm, parts per million. So it's defined as weight of substance over weight of solution times 10 power of 6. Okay, million is 6, so that's why times power of 6. Example of unit measured as ppm is milligram per liter or microgram per milliliter. So these are equivalent to parts per million. Okay. Next is parts per billion, ppb. Okay, so you see here is power of 9. Okay, referring to billion. So unit represent part per billion. Example are microgram per liter or nanogram per mil. So if you come across nanogram per mil or microgram per liter, it's actually representing parts per billion. Okay, next let us look at example of weight percent. Okay, weight over weight percent. So example here is if a ham contains 5 gram of fat in 200 gram of ham, so what is the percentage of weight over weight of fat in the ham sample? Okay, so 5 divided with 200 times 100. So of this 200 gram of ham, there is 2.5 weight over weight percent of fat. Next example is volume over volume. So if 10 ml of alcohol is dissolved in water to make 200 ml of solution, what is the concentration of this 200 ml? Okay, so 10 ml divided with 200 times 100, so it's actually 5 volume over volume percent of alcohol. Okay, another example is 5% aqueous solution of methanol would means 5 ml of pure methanol in water to give a total volume of 100 ml. Next is weight over volume. So weight over volume means weight of the solute in gram per volume of solution in mil. Okay, example is 5% aqueous silver nitrate often refers to a solution prepared by dissolving 5 gram of silver nitrate in sufficient water to give 100 ml of solution. Okay, so 5 gram over 100 ml times 100 will give, okay, will give 5% of silver nitrate. Okay. Okay, the last part is statistics. Statistics is a tool which helps us to accept conclusion that have a high probability of being correct and to reject conclusion that do not considered correct. Okay. First is mean. I'm sure you are very familiar with this already. So mean is the average obtained by dividing the sum of individual measurement by the number of measurement. Okay. So we'll look at an example later. Okay, to this. Next is median. Median is the middle value when we arrange the data from smallest to largest. Range is the difference between the largest and the smallest value in the data set. If the number of value for median, okay, if the set data is even number, so median will be taken from the two middle value and then obtain the average. Okay, example of calculation is here, shown here. So this is the sample data. So there are a set of 5 data. Okay, so you are asked to calculate the mean, median as well as range. So to calculate mean, we have to find the total value of all of these. Okay, so the sum is 12.4 and there are 1, 2, 3, 4, 5. 5 number of measurement. So the mean is 2.5. Next is to find median. So we arrange this in largest to smallest or smallest to largest and find the middle value. So median is 2.4. Range is the difference between the largest value and the smallest value. So 2.9 minus 2.2. So you get to 0.7. The next statistical tool is standard deviation. Okay, small letter s. So it's describing the spread of individual measurement about the mean. And this is the formula. Okay, where xi here is the individual measurement, x bar here is the mean, n minus 1 here in denominator is called as degree of freedom. Okay, so n is number of measurement, minus 1. Okay, and then square of this is called variance. Oh, sorry, square of this is called variance. So standard deviation is square root. Okay, now example is this set here. Okay, calculate the average and standard deviation for this set of data. And your answer should be this for for the average. Okay, this is the value of the data. This is the difference of the data and the average. Okay, so this is the average. So 15.67 minus 15.8. Okay, and this is the square of the difference between the each data and also average, and this is the sum. So to find the standard deviation, 0.0819, okay, sum of column 3 just now, divide with degree of freedom. So there are 3 data, okay, minus 1, then square root to get standard deviation. Okay, so if we don't have square root, then it's called variance. Okay, so 0.2 is the answer. So that concludes learning unit 1. Okay, so this is the practice question that you can try. Okay, so report the mean, median, range, and standard deviation for this data. Okay, so you should get this. Okay, for mean, median, and also range. Okay, this is the calculation part, and this is the summary of LU1. Okay, by now you should be able to accomplish all of this.